All right, so this is our second day looking at literal equations. Remember, we're just rearranging equations is all we're doing. But in this one, we're going to look at some real-world applications of rearranging equations. And so I actually have done some of these in the past, and these are actual things that businesses use to look at profit and how much to sell their product for, stuff like that. And so let's get into it. We're going to start with something we can all relate to, and that is sales tax. So sales tax is, and I'll try to make sure I explain this so that you all understand, the total price of something is the advertised price times the tax percentage plus the advertised price. So what I mean by that is this amount right here in parentheses, this is how much the sales tax is. And the way that they figure out how much tax to charge you is they take the price and times it by that tax percentage, and that's how much tax. Well, then you have to add on the sticker price, and then you get the total price that they charge you on the receipt. So, for example, you buy a case of Mountain Dew for $6.50, but when you check out, the price is actually $7.15. What was the sales tax? Well, maybe I should have been more clear on this. I meant to say, what was the sales tax percentage? Because the sales tax, you would just subtract the two and you get 65 cents, so the sales tax was 65 cents. But what was the percentage is what I'm trying to get at. So, if we plug it into this formula, the total price was $7.15. The advertised price was $6.50 times the sales tax, I'll just call T, and then add on the advertised price, which is $6.50. So if we're going to solve this for T, that's going to be kind of the goal here, is we want to get rid of that plus 650 first. So I'm going to subtract 650 minus 650. And I get 65 cents, so 0.65 equals 6.50 times T. And then I'm going to divide both sides by 6.50 divided by 6.50. And I end up with T equals 0.10. So the sales tax is 10%. That's how much it is. Okay, but what I really want you to notice is these steps that we took here. What we're going to be doing is we're going to be taking equations here and we're going to be solving them for a certain unknown. And so with this bottom equation here in red, it says the total price equals the advertised price times the tax percentage plus the advertised price. So that's what we just looked at. What I'm asking is, in general, what is the equation for tax percentage? So in other words, let's get tax percentage all by itself. And so in order to do that, what I'm going to do, just so we're not spending 5 hours writing stuff down, I'm going to give all of this stuff a letter variable. So total price, I'll just call P. Advertised price, I'll call A, times the tax, we'll call T, plus A, the advertised price again. So if we're trying to figure out what is the equation for T, we're just going to undo the order of operations just like we did in the previous lesson. So I'm going to subtract A from both sides. We've got P minus A equals A times T. And then if I want to get T all by itself, I'm going to divide by A. And so I have P minus A divided by A, all of that divided by A is T. So the tax percentage is equal to, I'm going to zoom in, so this was P minus A over A. So this is the total price minus advertised price all of that divided by the advertised price. Now, a lot of people will look at this and say, well, can't we just cancel out these A's? No, you can't, because the P doesn't have an A next to it, so it doesn't work like that. You could break this up into two different fractions, and you could say total price over advertised price minus advertised price over advertised price. Then you could cancel out the advertised prices in the other one, so it would be -1, but we'll just leave it like this. So what we're going to be doing is really the same as what we did before. We're just going to be using some real-world examples and assigning letters to them and then putting the words back in when we're done. So this is a sales tax example. Let's look at this one. It says in business analysis, oftentimes companies want to know if they're making enough money for the products they're providing. So if a company is making a product, they want to sell the product for more than it costs to make, than it costs them to make the product. The amount they charge extra is called markup. So what happens is you buy an iPhone, Apple doesn't cost them $1,100 for that iPhone 11. They probably spend less than $100 per phone for making it, and then they mark that up to a certain amount. And so when a company is figuring out a selling price, they are going to be using this formula in this box. And so at my previous company, before I was a teacher, I did this. We built produce racks for grocery stores, and we would always mark stuff up by about the same percent. So whatever it cost us to make it, we would mark it up by about 230%. And this is something that, when we're trying to analyze things, we are trying to figure out markup percentage and stuff like that. So what I'm going to do is I'm going to rewrite this equation using letters. So selling price using markup, I'm going to call that S. Cost of goods sold, I'm going to call that C, times the markup percent, which is M, plus the cost of goods sold. And guess what? This is almost the exact same thing as what we had before. So we're going to subtract C from both sides. We've got S minus C equals C times M. And then we're going to divide both sides by C, and we get M equals S minus C over C. In fact, it is the same thing as we did before, just with different letters. So the markup percent is, let's give ourselves some room. Equals S, which is the selling price using markup, minus cost of goods sold, all divided by cost of goods sold. Oftentimes you'll see that as COGS. So, like I said, not a whole lot different than what we're used to with the other equations we were doing in yesterday's lesson. We're just putting some words in real-world context to it. So some other stuff that might come up is in a common application for rearranging equations is in various science applications. So particularly physics. This is a chemistry example. This is called the ideal gas law. So this may look familiar from a chemistry course, or if you haven't taken chemistry, this is something that will come up. But the ideal gas law is PV equals nRT, and each of these letters has a different meaning to it. We're not going to get into that stuff right now, but let's rearrange these. This is something you'll often have to do in chemistry classes, rearrange them so you can solve it for a specific variable. So for this first one, it says solve it for P. So it's PV equals nRT, and we want to get P all by itself. So that one is actually pretty simple. We're just going to divide both sides by V, and P is all by itself. So we've got nRT divided by V. So kind of a one-step solver. If we want to solve it for R, PV equals nRT. Now we want to get R all by itself. So this is we're going to do in two steps. I'm going to divide by n first. So we've got PV over n equals RT. And then I'm going to divide by t because we're still multiplying. And just so you know, when you do a fraction divided by something, that divided by thing goes in the bottom. So it'd be PV over NT equals R. So there's a couple of examples with the ideal gas law. We're also going to look at an example here that would come from physics. And so we have A equals V squared over R. Let's solve it for V and solve it for R. So I'm going to rewrite it. A equals V squared over R. So if I want to solve for V, I'm dividing by R, so I'm going to multiply by R on both sides. And I get R times A equals V squared. And then if I want to get V all by itself, I need to get rid of the square, and I'm going to square root both sides. So then I get V equals the square root of R times A. All right, so that would be solved for V. And then let's solve the other one for R. So if we have A equals V squared over R, we want to get R all by itself. Now R is in the bottom, and so I want to get that out of the bottom. The way I'm going to do that is I'm going to multiply by R on both sides. Kind of like that first step on the other one. And so the reason I do that is I've got R times A equals V squared. And now I can get rid of the A, and R is all by itself. So I'm going to divide by A on both sides. And there you have it. Solve for R. So none of them were, I would say, super challenging, just a couple steps for each one. But these are all examples of something that you might run into in either a business class or a business setting, or in a physics or chemistry class. And so this stuff does come up quite regularly in, different subject areas. So that is day 2 of solving literal equations.